Hello, good morning. Welcome to coordinate geometry. This course, I believe you are going to find it to be very interesting, just like the other ones. Let me launch straight into the topics that we are going to be looking at. We are going to look at, first of all, we are going to look at coordinates. Coordinates. All right, that's the introduction. Okay. So under these coordinates, which is what we are going to be looking at in this very topic, we are going to look at the meaning of coordinates, definition of coordinates, and then we are going to look at something called the abscissa. Abscissa. We're going to look at something called the ordinate. Okay. Then we are going to look at some examples along the way. Then we are going to look at when you have 2 points, distance, we are going to look at distance between 2 points. We're going to look at distance between 2 points. We are going to look at, finally for today, we're going to look at construct the area of a triangle just based on the coordinates of it, based on the coordinates of its vertices. All right, so vertices. Okay, if we are able to get to this place today, then we would have conveniently introduced what coordinate geometry is. That is for today. That's today's topic, and the other topics which would be the subsequent weeks is okay. Why we call this one chapter 1, which is introduction, which is the easiest, simplest. We are going to have chapter 2. We're going to have chapter 2. Chapter 2 would be we study straight lines. So we'll study straight lines in chapter 2. Now in chapter 3, that is the third third version, we're looking at circles. So we study circles in terms of the coordinates. Then lastly, chapter this is chapter 3. Now chapter 4. Lastly, we shall be looking at what we call the conic section. All right, this conic section is divided into 3. So we are going to have a parabola. We are going to have hyperbola, and we are going to have ellipse. All right, so those are the 3. But this particular one, the parabola, is the one that we are going to majorly focus on. It appears to be the most important one that we would need to work with. So I'm going to save this page now, and I'm going to come back to. I'm going to probably send them to you later when the class is over, just for you to have something to go over. Now let's start with coordinates. So coordinates, to discuss coordinates, I would try to make this class as practical as possible so that we all follow. So we all know the Cartesian plane. All right, this is the y-axis and this is the x-axis. Okay, so we know that we call this place the origin. That's the origin, which is 0, 0. All right, or just 0. Okay, now let's assume that we have a point here. Let's call this point here point P. All right, Now point P is a position that is relative to two sides that we have. Is relative. So if you are looking at P, let's say this is an observer, you are looking at P from the top, then you are going to see it on this place. Let's call this place little x. Okay, let's call this place capital X, and we call this place capital Y as well. So we call this place little x. Now, if another observer is looking, is looking from this place, the person is going to actually see the reflection. We'll be seeing this point P against a point Y on the Y axis. Okay, so we now call so we now can see that we have okay, how am I going to describe it now? Let's say we have Py, which is the distance. Let me see if I can select another color. Let's make this thing as exciting as possible. Okay, so we now. Oh, I actually thought I picked the color. Sorry. Okay, okay. I hope I've picked the color now. So the distance from here, good, to this place, we know it is we can call it YP. Now the distance from this place to this place, we can call this one XP. XP. So we call YP. We call that the abscissa. Abscissa. And we call XP. We call that one the ordinate. All right. So when you now bring YP and the XP together, we call this one. This now becomes what we call coordinates. All right, coordinate. That is the point where like the point that describes. I mean, it's what describes the position of a point on a plane. All right, it's what describes the position of a point on a plane. So let's assume if let's say YP is a 4 and the XP is a 5, then our coordinates is going to be since this one is measuring along the okay, oh sorry, this is actually XP and this is YP. I'm so sorry about that. Yeah, sorry about that. So YP is a coordinate ordinate ordinate and the XP is the abscissa. That's the abscissa. I'm sorry about I think this thing is a little bit bold. Okay, so that's the way it is. So if your YP is 4 and your XP is say 5, then okay, so this is going to be XP YP. So we write the XP first, then the YP afterwards. So this is going to be 5, which is XP, comma 4, which is YP. So this is called the coordinate. All right, we are all familiar with it. If you have plotted the graph before, then you would understand what I just did. Okay, so let me use this part here as an example. All right, so we have that like this. This is the y-axis. So we have a point here. This place is 3. This place is 2. Then we know this is 3 comma 2, which is so x. So that's 0.3 comma 2. It's not a number. It's actually a point on a plane. So this is 0.3 comma 2. All right. So let me save the page again and see. Um, so now the we have discussed the abscissor, we have discussed the ordinate. It remains for us to start talking about any other thing afterwards. I think we should be talking about an example now. Let's talk about the example. Let's look at the example. I have these 3 points. I mean 4 points. Let's say A is 3 comma 4. B is minus 4 comma 2. C is I think I can make it a little bit bolder. Sorry. Okay. C is 2 comma 2, and the D is in fact minus 2 comma 6. All right, so let's put everything on the same Cartesian plane. Well, since we have some negatives, it means that it will be safe for us to draw a Cartesian plane like this. We are going to make it to be as beautiful as possible. This is the y-axis, and this is the x-axis. This is the origin 0. All right. So let's label everything out once and for all. We have I think the smallest number we have for on the x-axis, on the positive x-axis is 2, which is this guy. After that, we have 3. We have 3. All right. So on the negative side, the largest one we have is minus 2, and we have minus 4. On the y-axis, the smallest one we have is 2. I think we have a 6. Let's put our 6 here, even though it doesn't look good. Then let's put our 4 here, this 4. Okay, now let's look at the first one, 3, coordinate 3, comma 4. Then we are looking at 3 here. Okay, let me use the black pen. 3, 4, 3. So this is a point A. All right, that's point A. I hope you are following me. I'm going to go as slowly as possible so that we will be able to understand what I'm doing. So let's look at B. Let's choose a red color just to make things livelier. Okay, okay, we are picking B to be minus 4 on the x-axis, which is this. Okay, sorry. Okay, sorry. So minus 4 here is going against 2 plus 2. Good. So minus 4. So plus 2 comes here. So here that's minus 4 comma 2, and that's point B. Point B. Okay, let me make it as clearly as possible. Okay, yeah. Now the third one is C, which is 2 comma 2. So there's the 2 is here. Another 2 is there. Let's pick another color. There's no reason why we can't be exciting. So I'm picking blue, 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 blue. So that's 2. That's 2. 2. That's 2 comma 2, and that's C. All right, that's C. Then lastly, we have okay, we have minus 2 on the x-axis, and we have 6. Oops, everything is on the north hemisphere, on the positive north hemisphere. Sure. Okay, so we have minus 2. Let's pick another color. Why not? Why not? Why not? Why not? I would like to pick this olive green. Okay. Okay. Yep. So we have minus 2 and 6. So we move 6 here, and we move -6 here. Okay, let's make it as clear as possible. So we have that. So we can call this -2, comma 6, and that's going to be my D. So that is it. We can now see everything, on the same plane. So they are points. We can't say a point is greater than another point. Just they are just points. They are scattered all over the place. All right. So that's the example. Now we now have these points everywhere. The next thing we should be talking about now. Let me pick a black color now. Let me pick a black color. Something quite black. Okay. Sorry. All right. So now this is a point here, and this is another point here. We can now be talking about the distance between them. All right. So how do you measure the distance between these 2 points? Exactly the way your phone, Google Map on your phone can tell you the distance between 2 points, maybe two cities, Lagos and Abuja, and all that. So that is what we want to learn right now. So I'm going to save this page and create a new page. Okay, so the new page has been created. Okay, so now the new topic is distance between two points. Okay, distance between 2 points. So the distance between 2 points. So this is what we want to look at now. So what we do first is that let's make it let's it will be easier for us to learn the theory. Um, it will be easier for us to learn the theory on on okay. All right, let me divide the page into two. Okay, so I'm going to draw here the Cartesian coordinate. I've drawn it here. This is a point here, and this is another point here. Okay, so this point, let's say this place is x1 and y1, and this place is x2 and y2, which means that this point here is what? Answer that question before I tell you. This point here is x1 y1, and this point here is x2 y2. So of course we put a comma between. So now we want to find the distance between the 2 points. All right, we want to find the distance between the 2 points. It's actually very, very simple. Very, very simple. Now, now, what is the length from this point down to this place? If you know it, you know that that's y1. Okay, that's y1. And what's the length from this place to this place? If you see, it's not difficult for you to see that that is so this is this is y1, and this is actually y2, because y2 because of this y2 here. Okay, so that's y2. So if that's the case, let's create a right angle triangle from what we have. So it means that okay, so let's call this place A, call this place B, and call this place C. So we can see, and let's call this place let's say P and Q. All right, so just stay with me. We know that that's point AB. So we now have a right angle triangle, which is like this, where this one is A, B, and C. Now we know that AB is nothing but when you take a good look at it, it's going to be the entire stretch of okay, y2. So from here, from this place to this place, that's y2. All right. So to get AB, so you have to subtract, and from here to this place, that's as in from here to this place, that's y1. All right. So AB is going to be y2 minus y1. This place is going to be y2 minus y1. All right. I think that is clear. So CB, likewise, since from origin here, let me pick a new color to make this thing clearer. Okay, from the origin, here to this place, that's actually x2. But from the origin here to this place, that's x1. So the distance between these two will now be x2 minus x1. So this is going to be x2 minus x1. All right, now the distance we are looking for is there. Is the right angle triangle. We have the opposite, we have the adjacent. We only have to calculate the hypotenuse. So we go by that great mathematician Pythagoras. So by Pythagoras theorem, theorem, we know that CA is going to be AB squared, CA squared, sorry, is going to be AB squared plus the BC squared, which of course is going to be y2 minus y1 all squared plus x2 minus x1 all squared. So that's going to be CA squared. So CA itself would now be, just take the square root of the entire stretch. So we have y2 minus y1 squared plus x2 minus x1 squared. And that is all. That's how you find the distance between two points. That's how you find the distance between points. We may quickly look at an example. Let's look at an example. I've saved that page. Let's look at an example. All right. So the example is like find the distance between points 4,5 A and B 2,3. Right, B 2,3. Okay, so 5, so let's sketch it here. Let's sketch it here. We know it's going to be like this. Let's divide this page into two so that we know that we do our working on the right hand side. So we have 4,3. So let's say okay, so we are going to have 2, 4 here, and on the y-axis we are going to have 3, 3, 3. Okay. Oh, I think it's 4,5. So we are going to have 3, 5. So the first one is 4,5, which is going to be here. The other one is 2,3, which is going to be here. So we are asked to find this distance. We have to find this distance. Okay, so this point here is a 2,3. This point here is which is I think we call that one B, and this is A, which is 4,3 A. All right, so we are finding the distance between the two of them. So what you do is that you can now say A. You can use the formula straight. All right, if you remember it. If you don't remember it, you know how we derive it. So it's going to be, if you remember it, it's going to be, you subtract the abscissors, Then you subtract the coordinates, square both, and add. It doesn't really matter. Add, then you take the square root. So it doesn't really matter the order. So just subtract 4 from 2 and square it, and then add it to 3. I think the other one is 5. Yeah. Okay. This is 5. Yeah. So subtract it from okay, 5 minus 3. 5 minus 3, then square it again. This is going to give you the square root of okay, I don't think I need to make my square root that large, so let me just cut it around this place. Or let me, for the sake of neatness, let me do it. Okay, so it's going to be 2 squared plus 2 squared. So it's going to be what? 4 plus 4, which is going to give us root of 8, which is going to give us 2 root 2. So that's the units, irrespective of what the units will be. So we have now officially known how to calculate the distance between the 2 points, both theoretically and practically. So we have done the theory of it. Now we have also done the practical of it. So I'm saving the page, and I'm going to the real beautiful, beautiful part of this journey, which is how can we find the area of a triangle just from the coordinates. All right. So I think I want to take a delightful color for this. This is really special, special, special for me. Okay, I think I've okay. Okay, let me pick blue, blue. All right. So now this may take more than 2 or 3 pages to explain, but then you stay with me. So how to find the area of a triangle in terms of the coordinates of its vertices. Now, this is a very interesting thing. Okay, we all know that the area of a triangle is usually half base times height. Now, so we are now okay. So let's talk about the vertices of a triangle. So let me describe that. Okay, well, we'll talk about that. So let me draw out this triangle first. So I'm going to draw out the triangle like this. Okay, so I'm going to use this one as a demonstration of what we want to do. So this is we call this one A. Call this place B. We call this place C. All right, those 3 points, A, B, and C, those are the vertices of the triangle. So we label this one as x1, y1. We label this one as x2, y2. We label this place as x3, y3. And they are saying that without knowing the lengths of all these things, how can we determine the area of this triangle? Okay, how can we determine the area of this triangle just from the coordinate system? So we, like I said, we know that area of a triangle is half base times height. But in this case, what is the base? What is the height? We have no idea what they are. All right. So how do we go about that? How do we go about that? And that's what we are going to learn next. All right. So I'm going to save the page. Like I said, it's a huge, huge proof, and that will require you to stay with me all through. So I'm going to go as slowly as possible. I'm going to change colors as many times as possible, as long just for you to understand what I want to do. So I'm going to draw my Cartesian coordinate here. So I'm going to put my triangle inside it. Okay, that one is not coming out well. Okay, okay, okay. I think it's better now. X and Y. So I'm going to put a triangle in between it. I'm going to make the triangle to be as delightful as possible. Okay, so let me extend this a little so that it can cover my triangle properly. So now there you are. We have my triangle. We have okay. This is a x1. Then this is going to be y1. So here, this is going to be x2, and it's going to be y2, and here this is going to be x3, and this place is going to be my y3. Okay, so you can understand the reason why we have that. So this is x1 y1, this is x2 y2, this is x3 y3. All right, so now if you take a good look at it, you can see that we have three. Okay, let's label it properly. Let me call this place A, B, C, D, E. Okay, that's what we have. Yeah, so excuse me. All right, so we have that. Now, if you look at this thing, you will see, how many trapezium can we see on this drawing? If you take a good look at it, I can count three conveniently. The first trapezium, so let's say trapezium 1, or let's say trapezium A, that's going to be the shape A, B, D, and E. All right, that's the biggest one. I think you can just follow what I'm doing. I'm going to go as slowly as possible. Okay, so trap 2, and that's the good thing about these videos. You can pause it and look, then push it back a little, just to see what we have discussed that you don't quite understand and all. All right, so trapezium 2 will be this one. Okay, let me pick a red. Let me pick a red color. Okay. Okay, so we have discussed this one as the first trapezium. Okay, now we are discussing the second trapezium. Let's pick a black to describe the second trapezium. So this is the second trapezium. All right, now let's pick something greenish, something exciting. Yeah, good. Now this is going to be my third trapezium. All right, so let me go back to the blue. At least you can now see the trapezium. They have shown where they are. So let me now, the second trapezium is actually what? A, C. Okay, I think I can put F here. I can put F there. Let me put it properly. F. All right. Okay, A, C, F, E. All right, and the third trapezium, the last trapezium, is going to be trap C. It's going to be, we can say C, B. If you are going clockwise, C, B, D, and F. Now, if you take a very good look at it, this is the triangle. This is the triangle we are seeking. That place I'm shading, that's the area of the triangle. Meaning that if we add this trapezium 2, we add it to trapezium 3, then we can subtract it from trapezium 1, the entire trapezium 1, and we are going to have, what we'll have left is this triangle. So our action plan is that triangle A, B, C will be obtained from, let me come down here, trapezium A, B, D, E minus, or let me say from trap A, you take away trap B plus trap C. Okay, this is B, sorry. Trap B plus trap C. That is A, B, C, D. I mean A, B, D, E minus A, C, F, E plus C, B, D, F. So I'm trying to manage my space as much as possible. So we have that one. So I think it's okay if we close it. So how do we now find these values? How do we find these values? It's going to be a little bit harsh for me to do this because I really want to squeeze everything on this page. I'm working from my head. So well, let's see how it goes. So what's going to be trap? So what I have here is wrong. Okay, it's correct. So what's trap A? So we should find trap A first. Trapezium A. You know the area of a trapezium is a trap is 1/2 into A plus B plus H, where A and B are the size and H is the height. So if you look at the first trapezium, if you look at the first trapezium, we have it has a okay, we have, okay, let me just risk it. The first trapezium is like this. Let me just risk it. The first trapezium is like this, labeled as x1, x3. Okay, okay, x1, x3. This is a x1, y1, this point, and this is a x3, y3, that point. All right, so if we're looking at, okay, this one is resting on the x-axis. All right, so this is the x-axis. All right, so it means that distance from here to here is actually x1. So it means that this A is x1 and this B is of course x3, and this distance here is going to be x3 minus x1. So the area, so trap A is actually going to be x1 plus x3. That's going to be the length of the standing sides times the height, which is x3 minus x1. Maybe we should just resolve that one. That's going to be x1 plus x1 x3 minus x1. I think I might have x1, okay, plus x3 minus x3 x1. Okay, let's have that one. So I may have to write that down so that just give me a second. in the second as trap A equals x1 x3 minus x1 x1 plus x3 x3 minus x3 x1. So we are done with trapezium A. Now let's look at trapezium 2. I think trapezium 2 is going to be like this. It's not as large, so we make it smallish. All right. So we have a x1. Um, then this is the coordinate x1. This is x1. This is going to be um, x1. This is x1 y1. Okay, I think I've made a mistake. I'm so sorry. Here, like I told you, I was working from my head. So here is actually y1. All right, because it's the ordinate, which is y1, and this is going to be y3. Okay, so that's going to be y1 plus y3. I'm so sorry about that. So you can say no one is beyond mistake. I'm not saying I'm supposed to be beyond mistake or anything. So this is a y1 x3 y1 x1. It actually looked weird when I was doing it, but since I thought the math was good, so x3, so this is going to be y3 x3, and this is going to be y3 x1. Yeah, I think we are good like that. So let me rewrite the nonsense I have there. So this is y, this is y1 y1, this is y3, this is y3. So I've put it down so that when I clear the board, I would be able to see it properly. So this is going to be here. It's going to be y1. All right, but this point here is x1, and this point here is x3, which means this place is x3 minus x1. Sorry, this is x2. All right, so this is going to be x2 minus x1. I'm so sorry with the whole of this mess, but just bear with me. I'm going to be fluid very soon. This is going to be y2. If you take a look at it here, okay. If you take a look at it here, you can see that is y2. All right. So we know that trap 2 then, trap B is going to be y1, which is the first length, plus y2, which is the second length, times the height, which is x2 minus x1, which is going to give us y1 x2 minus y1 x1 minus I think okay y1 x2. All right, y1 x1, that's minus, then plus y1 x2, sorry, x, what am I, y2, sorry, y2 x1, or is it x2, sorry, y2 x2 minus y2 x1. Okay, let me cancel it out. I can see it's hiding. So it's going to be y1 x2, all right, minus y1 x1, all right, plus y2 x2 minus y2 x1. Okay, so that is that. So let me write it down also before I move on to the third trapezium. So we have this one has a y1 x2 minus y1 x1 plus y2 x2 minus y2 x1. Okay, so I think we're good. Now the third trapezium would be it has this shorthand around this place. It goes up a bit, then comes down like this, then comes to this place. All right. Now this is going to be y2 here. This is going to be y3 here. This place is going to be x3 minus x2. Okay, so we can now start talking about trap 3. Trap 3, that's going to be y2 plus y3 times x3 minus x2. Okay, x3 minus x2. Let me try something else. Excuse me. That one is not coming out well. So let me see if I can squeeze it in. Okay, that's x3 x3 minus x2. Okay, I think it's better that way. So if you open this bracket now, it's going to give you, which is going to give you um, y2 x3 minus y2 x2 plus y3 x3 minus y3 x2. Okay, so let me write it down so that I can clear the entire page, and we can. So y2 x3 minus y2 x2 plus y3 x3 minus y3 x2. Okay, so that's what it's going to be. It's a mess, but it doesn't matter. If you read it along with me, then you're going to get it. So I've cleared the pages, and I'm creating a new page for us to work with. Okay, and we can now start talking about. So we know that from what we've done earlier, we know that trap 1, that the triangle ABC triangle is in fact trap A minus trap B plus trap C. So that is what. So we have found trap A to be x1, sorry, y1 x3 minus y1 x1 plus y3 x3 minus y3 x1. That's the first one. Now plus, then we can now open the brackets like this. Okay, don't let me open the bracket there. I have the entire space to play with. So I'm going to open the bracket right beneath it here. Is it plus or minus? It's minus. So it's minus. So minus. So I'm going to open the bracket right here, and I'm going to say y1 x2 minus y1 x1 plus y2 x3. Don't get discouraged. This thing is actually really simple. What did I just do? That's y1 x1, y2 x2, not x3, y2 x3, x2 minus y2 x1, yeah, plus then circular brackets will come in. We have y2 x3 minus y2 x2 plus y3 x3 minus y3 x2. Okay, so I think I'm in a very convenient place now. So this would imply y1 x3 minus y1 x1 plus y3 x3 minus y3 x1. I might have made a mistake, but then let me just be positive. This, like, for instance, okay, now minus. So we use that minus to open the bracket up. So everything in here would change signs. So this is going to be y1 x2 minus plus y1 x1 minus y2 x2 plus y2 x1. All right, it really doesn't matter. Minus y2 x3 plus y2 x2 minus y3 x3 plus y3 x2. So now let's see what will cancel out each other. This will cancel out this automatically. So let's look at y2 x2. They will cancel out each other, and then obviously y1 and this one will cancel out each other. Those are all that will cancel out each other. Then we now have y1 x3, all right, minus y3 x1 minus y1 x2, okay, plus y2 x1, those are the survivors, minus y2 x3, all right, plus y3 x2 will now be the area of the triangle. I think that's exciting. So that's the area of the triangle. So if you are given x1, y1, x2, y2, x3, y3 as coordinates, fill in the values of these guys. Fill in the values inside this magnificent formula, and the triangle formed by these 3 points, the area would come out. All right, so that is what I have gotten for you as an introduction to this class. Please feel free to comment uh, uh, when you see it on YouTube. Feel free to comment beneath it. If you have questions, you can ask me afterwards. Thank you very much. I'm going to be sending in this second video later.